Now, in part one of this episode, I want to talk a little bit about what are called mixed numbers. And mixed numbers are when you have a whole number and a fraction. So, what you might see is something like this, the number 2 directly next to 1/5. And what this communicates to you is that you have 2 and 1/5. Or put another way, 2 plus 1/5. If you have a mixed number like this one, a whole number 2 and a small fraction next to it, and if you want to convert that to a single fraction, then all you have to do is add together 2 and 1/5, the same way that we added fractions together in episode 6 that we just finished talking about yesterday. I would think about 2 as 2 over 1. And then I would try to get these two quantities to have the same denominator. Instead of 2 over 1, for example, I'll try and convert that first number so that it's over 5. So to change 1 into 5, all I have to do is multiply by 5, and I get 2 times 5, 10 in the numerator over 5, added with 1 in the numerator over 5. Now that these two quantities have the same denominator, now that the slices are the same size, all I have to do is add together the numerators, which represents the number of slices. If I have 10 fifths and I have 1/5, then 10 plus 1 in total gives me 11 slices of this size. So this is how I would convert a mixed number to a fraction. If I have 2 and 1/5, if I have 2 plus 1/5, then I can convert that mixed number to a fraction just by adding those quantities together. Now I want to think about what we did, and in thinking about what we did, I want to come up with a shortcut method that will allow us to do this conversion maybe a little bit more quickly. Notice what ended up happening in the end of this problem. I took my number 2, my 2 that was the whole number part of this mixed number. 2 got multiplied by 5, which turned it into 10. And then that 10 got added to the 1 that I had in the 1/5. 2 times 5 plus 1. So if I think about what we did in this problem, I just took my 2 and multiplied it by this denominator 5, 2 times 5, and then I added it to 1. And this is how we can convert mixed numbers to fractions relatively quickly. We can take the whole number part times the denominator and then add it to the numerator. So to give you another example, if somebody said, take 5 and 3/4 and convert that to a fraction, then I could convert this mixed number to a fraction very quickly using this idea. I would take the whole number part 5, and I would multiply that by the denominator, 5 times 4, and then I would add that to the 3 slices that I already have. And that would give me the number 20 plus 3. That would give me the number 23. And 23 is what I would put over 4. So this would be 5 and 3/4 as a fraction. 5 and 3/4, which I have gotten just by taking 5 times 4 plus 3 and then putting that over the denominator of 4. Now, if you have to go backward, and if you have to convert a fraction back to a mixed number, then this is the process that you can use. For example, if someone says to me, I have 16 thirds, convert that to a mixed number. In other words, tell me how many whole units you're dealing with when you have 16 thirds. First, let me draw this process out. If I have 16 thirds, then I'm cutting my pizzas into 3 pieces. And I have 16 such slices. So if I distribute those 16 pieces across a certain number of pizzas, then I'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This visually represents 16 slices where the size is indicated by a denominator of 3. Now, if I look at this picture, I can see that 16 slices of this size has given me 1, 2, 3, 4, 5 full pizzas and then 1/3 left over. So this would be, I can see from the picture, 5 and 1/3, or as we're writing it, 5, a big 5 next to the fraction 1/3. That would be 16 over 3 as a mixed number, the whole number 5 and the fraction 1/3. Now, if you're not in the situation where you can easily answer the question just using a drawing, here is another way to go about converting a fraction to a mixed number. Here's an alternative method. The first thing that you can ask yourself, the alternative method is to think about this as a division problem. We remember that this horizontal bar is another way to represent division. So if I had, instead of 16, if I had 15 over 3, then we could think about that as 15 divided by 3. I'm going to think about this as 16 divided by 3, and I'm going to ask myself, how many times does 3 go into 16? How many 3's fit into 16 evenly? Well, if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 units, I can see that 3 goes into 16 1, 2, 3, 4, 5 times evenly, with 1 left over. So I was able to divide 16 by 3 5 times, and then there was 1 left over, which was too small to be divided by 3 any further. So this is another way to think about 16 over 3 and convert that fraction to a mixed number. Ask yourself, how many times does 3 go into 16 all the way? 3 goes into 16 5 times in total, but this leaves 1 left over that was too small to actually be divided by 3 evenly. So I have 5 and 1 divided by 3 left over. Now, when you're dealing with calculations that involve mixed numbers like this one, then we can do calculations involving mixed numbers just by converting those mixed numbers to fractions and doing the calculations just the same way that we did in episode 5 and episode 6. If you're doing a calculation involving a mixed number, step number 1 is to convert that mixed number to a fraction. Then do the calculations with the fractions. And if the question asks you to, when you're finished with the calculation, you can convert back to a mixed number. But I personally would probably only do this if the question asked me to. I probably would not convert my answer back to a mixed number unless I was required to. Somebody says I have 1 7/8 of a pepperoni pizza, and I want to divide that pepperoni pizza equally among 4 people. If that's what I wanted to do, how much pizza would each person get? So this is a problem involving a mixed number because I have 1 7/8, one whole pepperoni pizza, and 7 out of the 8 slices of another pepperoni pizza. And my goal is to divide that by 4. So the first thing that I'm going to do to complete this calculation is to rewrite this mixed number here in the front so that it is in the form of a single fraction with no whole number part sticking out in front. And so I'm going to go ahead and do the whole number portion times the denominator, 1 times 8, plus the numerator, 7, and that'll give me 15. So as a fraction, this guy is going to be 15/8. And that's what I want to divide by 4. Now, do you remember how to divide 2 fractions? We had our mnemonic KCF, keep, change, flip, keep the first fraction, change the operation from division to multiplication, and then multiply by the reciprocal, flip the second fraction upside down. Now, do you remember how to multiply 2 fractions together? When we multiply 2 fractions together, then we multiply the 2 numerators, 15 times 1, and that's just 15, and we multiply the 2 denominators, 8 times 4, so that's 32 in total here. What if I did a calculation like this one? I have 3 1/4, and I want to remove 2 1/8. To do a calculation like this one, I could, for example, start by rewriting 3 1/4 as a single fraction and rewriting 2 1/8 as a single fraction. So to rewrite 3 1/4, I'll do 3 times 4 plus 1, 13. That's 13/4. And to rewrite 2 1/8, I have in the numerator 2 times 8 plus 1, 17/8. And my goal is to subtract these. Now, they don't have the same denominator right now, so I cannot perform this subtraction as written. But I'm going to modify the slices in the first fraction so that they are the same size as the slices in the second fraction. So I apply a 2 to the numerator and the denominator of the first fraction. And if I do that, it changes the first fraction into 26/8. And then I take 26/8 and I remove 17/8. And 26 remove 17 gives me 9 left over. 9 slices of size 1/8. Now, this is a pretty big amount where the numerator is larger than the denominator. So if I wanted to, I could finish by rewriting this as a mixed number. And I could say, how many times does 8 go into 9, for example? Well, 8 goes into 9 one time fully. If I had a pile of 9 objects, then I would be able to divide 8 into that evenly once. But that would leave one object left over, which could not be divided by 8. So I would have 1 1/8. as an optional way to write my final answer here as a mixed number instead.